So you in the class, Jayati ma'am has done the Newton Cotes formula, and that is the Newton formula for interpolation. From that, I think trapezoidal, Simpson's 1/3 rule, and Simpson's 3/8 rule. All the three come from that polynomial only, and there are different number of terms in these three type of integration. So that's the only difference here, and the segments are equally spaced. So in the Newton Cotes formula, that is the key, and that's what it differentiates it from the Gaussian integration. So you're not using Gaussian integration here, I think. So in trapezoidal, you have to use the first two terms, that y0 and delta y0 term, and the Simpson's 1/3 rule, you have to use the first three terms, y0, delta y0, and delta square y0. And Simpson's 3/8 rule, you have to use one more term. And in the first question, you have to make a program so that you find it for n segments, not just two segments, like or one segment. So normally, if you have an integration, you have to do a numerical integration using trapezoidal rule. You just used to do what? You used to take the value at the lower limit and the upper limit, and divided by 2 into the length of the segment, right? But now you have to make multiple segments, and then you have to apply these rules in each segment, and you have to write a computer program for that. Okay, in the first question you have to do this.
Sir, what is n here? I mean, what do we take the step size?
Okay, right. So you have to take n as a variable. That's what you have to write a program for, right? You need to take input n and then find the integration using these different methods, right?
Yes.
Is it okay?
Sir, sir, do we have to do the repeated something? Repeated trapezoidal rule and repeated Simpsons. Such that things, such like.
So repeated, what do you mean by repeated? I mean in for each
Sir,
segment, right?
yes, sir.
Yeah. So if you are using trapezoidal rule and you are using, say, n equals more than 1, so you need to apply trapezoidal rule in both the segments, right? So that's that. If you say that it is repeated, then yeah, that's what you have to do. Or you can just find out the formula for n segments, taking n as input, n maybe 1 or 2 or anything, right? Yeah, is there
So,
a
sir,
doubt?
for example, if we have like maybe the user might input n equals to 3, so we have to take three segments, right?
3 segments for trapezoidal rule, right?
Yes. So finally, we'll have to print the summation of those three segments, right? Or
Yes,
we have to print the individual integration for all the three segments. We have to
you
print the
have to,
final sum, right?
yes, you have to, finally you have to integrate from 0 to 1. You divide
Oh,
it into n segments and you have to sum it up, right?
okay.
So
So
there
what
is
is the
a nice
significance?
formula that comes, I think. Yeah, what are you asking, Sushank?
So what is the significance of user friendly here? Like, is it related to the display of the data?
I think I think user friendly means, uh, I think she meant by taking n as input. So you can put n as anything, right? Any number of segments you can have, and you find the trapezoidal rule with that. You find the integration using trapezoidal rule or the other two methods. Because what will happen is, if you take n as 1 or 2 or 3, the the numerical value of integration will change every time, and the user just have to put the input as 1 or 2 or 3, anything. So that becomes user friendly. I think that's what she meant, nothing else.
So,
So
but in
don't worry too
the
much about that.
second part of the first question, it
Hmm.
says that we have to draw the true error as a function of number of segments.
Yes.
And also we have to find the trend in it. So, like, do we do that after the after the first part? Like first the user will input n. Now,
Mhm.
how many times will do we have to do that? Like, uh,
Okay.
after that
Okay.
we'll have to show the trend as well, right? So then we have to use all values of n, or at least till some value 17, 20 or whatever.
Right. Right. Good question. So you want to do it in a single code, right? That's what you are asking.
Yes, I know. I'm also asking, like, do we have to ask the user for the input, or since in the second word we already have to show the graph or the trend for different values.
No, in the first part you will have to write it for any variable n, because how will you do that if you give a specific value of n, or if you, right, if you take, or maybe if you, do you want to take n equals 1 to 20 and then calculate it for everything and then plot the graph? You want to do that?
Like, final results could be displayed for different ends in each method.
So that would be easy, right? What I'm saying is you compute it for any n, and then try it for at least 10 to 15 n's, and just write the final answer and then plot it in an excel file, right? That would be easier. You find the true error, you find the you have the n, you find the true error using the code for any n, and you plot it in an excel file, right? Or maybe you can write another code which takes this function to form a which takes a function, which makes a function, and which gives a integral for trapezoidal, and you run it over a loop so that you find it for different ends. Maybe you can do that also.
Right.
So
That is what I'm asking. Like, in the second question, that is what is asked. In my opinion. So
okay, so you
in
can
the
do
first
that
question,
also, right?
we can do that as well, right?
Yeah.
Like, I will ask the user once for the n input and then show in the data for rest of the n's.
Yeah, that's fine, you can do that.
Thank you.
Sir, can we do this for other ends separately in Excel? Like we can write the program which takes an input of n from the user and displays the integration for that.
Okay.
And for different n, we can make the trend in Excel, I think.
Yes, so that's what I think I told initially, right? So yes, you can do that, but you have to mention that in your report what you have done in the code, because yeah, that would be helpful in your evaluation. So you can do
Okay, sir.
either you can run it over a loop and get the graph, or maybe do get the answers in an Excel file and then plot. Okay.
Okay, sir.
Mm. Anyone has doubt in the first question now?
So,
Hmm.
so in question one, what does it mean by tested by integrating? I mean, the final integration value is already given. So what do we need to test by integrating that function?
Okay. Okay, so in the trapezoidal or any of the rules which are given here, we just use the function value at certain points, right?
Yes, sir.
And the true value of integration is given, right?
Yes.
And so it doesn't matter what the function is, you can write the code and knowing the function values, right? If you get a analytical function, you can just put it in the code and then find the function values, because you just need the function values at certain points to find the integral. So that's why you need to test it with this thing. And so you can show it that particularly for this function you have found the integral, and now the true value is given, and et is the truncation error, I think. So truncation error can vary depending upon the zeta, but you can find out the true error using the true value. And zeta, probably you can find the maximum value of zeta or maybe the range of zeta. So that's how you can find out ET, the truncation error, uh, for the given numerical integration, right? If you are using trapezoidal, there is, I think, the third term or something. After that, it is neglected. So the f dash 3, or you have to check that what is the f dash value you need to take, and right. So it is the truncation error, and the true value is given for to find the true error.
Okay, sir.
Anybody has any doubt in the specifics of trapezoidal or Simpsons, or Simpsons 1 by third, or Simpsons 3 by 8 rule?
Sir, I have a doubt in this one. Use the true value of 0.60 to compute epsilon t. So after integrating, we have to put this value and find the true value.
After integrating what?
Sir, the given function.
He's saying that after integrating also we'll get the same value, right? So what is the need of that integration if we already have the true value?
So
No,
analytical integration, what are you saying?
sir, it is saying that use the true value for compute epsilon t. So in which equation we have to put to get the value of epsilon t?
I
एप्सिलॉन
think
तो परसेंटेज एरर होगा ना, ट्रू परसेंटेज, ट्रू एरर माइनस जो हमें मिल, ट्रू आंसर जो माइनस जो हमें मिल रहा है.
आई थिंक वही है, जो हम कोड से जो आंसर आएगा और ट्रू वैल्यू है उसका डिफरेंस का मॉड लेके
Exactly.
परसेंटेज निकालेंगे, बस वो एप्सिलॉन ही होगा.
इसीलिए दिया हुआ है वो ट्रू वैल्यू.
so. Has anyone found out the exact integral value of this? So is this the same which is given here? Maybe try it now. Find out the exact integral of this 0 to 1. Okay, so I also checked it. So it's the same value 0.602 something. So ET should be, I think it should be truncation error, but here true value needs to be used to find ET, then find treat it as true error and true percentage error, or percentage error maybe, that's what you are saying. And in the B you have to just take it as true error, so don't take percentage in B. Okay. If anyone still has any doubt in the first question, please ask now.
Sir, in B part, we have to use the formula derived in the class, or we use a simple formula, true value minus approximated value, to find the error.
Yes, that's exactly what you have to use, true minus approximated.
Okay.
So what else have you been told in class?
Sir, in example, the ma'am derived the formula from that part. He find the from that part she find the errors.
The truncation error formula.
Yes, sir.
So you have to use true error here. So don't use the truncation error formula, because you don't know the exact value of the truncation error, and you don't know zeta, so don't use that. Use the true error because you know exact value, and exact value is also given here, so it should be easy enough. Okay, so we'll move on to the next question if everyone is clear with the first one. Okay, so the second question is relatively easier. You don't have to do much. So you have to, so the XA given is 0.9, right? And the factor before the integration is 2, given as 2 meter cube, so you take it as 2, and n equals 1.25. Now again, I don't think here okay, find the value of n subdomains required in each case. So again you have to use the uh, computer program which you will do in the first question. I think the similar thing is required here, but now the convergence is given. So for this you can integrate it. I think you need to first manually integrate it and find the exact value, right? And then you can find the tolerance.
What is the like? What are the intervals, like 0 to what? The
0
X
to,
exit value.
okay, so XA exit is given, right? 90% conversion. Then what would be XA? 90% conversion.
Zero 0.9.
Yes, exactly, 0.9. Right? And you have to find the value of n so that the error uh, is below this tolerance level. Now again, you need to check with different n's here, different number of segments. subdomains here are the number of segments you are taking, right? And you need to check again and again what is the true error here. If it goes below the given convergence, then you report the n for the different formula. So one more thing I forgot to mention in the first one, which applies in the second one also, that the Simpson's 1/3 rule, n should be the multiple of 2, and in Simpson's 3/8 rule, n should be multiple of 3, right? Can anyone
Yes,
tell
sir.
why?
So because we take those many terms together to form a,
You're not audible properly.
so the interval is made such. I mean, Simpson only works with even.
Yes, Simpson's 1/3 rule, we need to have even number of n. So because we are using 3 points to find the integral, right? So 3 point will make two segments, and so that would be one whole segment for which you are applying Simpson's 1/3, and using 4 points you will apply Simpson's 3/8 rule. Okay, so that you have to keep in mind.
So, sir, in question 1, then when we'll plot, so the plot will be like 1, 3, 5 that way for the Simpsons code.
Okay. For the Simpsons, n should be a multiple of 2. Okay, and so you plot it, probably you can plot it like 2, 4, 6 maybe, for 2, 4, 6, or you can say that, or you can also say that probably using the 3 points you are saying it as a single segment. You can define it as you want, but you need to plot it accordingly what you have taken as the definition. If you are taking the 3 point as one segment, because you are not using all those 3 points again, because you are moving to the next 3 points, right? Using the upper limit of the first segment and then going on to the next segment. So you can define it as you want. If you define it 3 point as one segment, then it will be just like 1, 2, 3. And if you take 3 points as two segments, then it will be like n equals 2, n equals 4, 6, right? So the trend should be similar, and whatever the x-axis you have taken, the trend will be similar in y. So that's the main point here. Is that clear?
But sir, the main difference between Simpson's 1/3 and 3/8 rule is that the in 1/3 we take 3 points and 3/8 we take 4 points. So maybe it get different when we take n equals to 2. Even in
I
Simpson's
mean,
1/3.
yeah, trend will be different, but what if you take even points or odd points also, whatever you take, the trend in Simpson's 1/3 rule will be same, right? If you take the 3 points at one segment or the 3 point as two segments, the trend I'm talking about in the same formula, not in different formula. Someone asked that what should we take as n? Should we take as 2, 4, 6 or 1, 2, 3, right? So in these in both the cases, I mean, if you take x-axis as 1, 2, 3, 4 or 2, 4, 6, 8, So in both the cases, I think you'll get the same trend in y in Simpson's 1/3 formula. That I'm not talking about comparing Simpson's 1/3 and 3/8. The trend should be similar. Rohit, is it clear?
Yes, sir.
Okay. So yeah, so both the questions are, I think, basically the same questions. In the second question, you just have to find the exact value of n for which the tolerance level the error goes below the tolerance level. So it's the same question essentially. So if you are able to do the first one, you can do the second one also.
Could you repeat what you have to do for the 90% conversion part also? And the volume part 90%.
Okay, so what exactly is your doubt?
So they gave the integral from 0 to exit,
Mm-hmm.
and उसमें they are saying कि हमें we have find the volume required for 90% conversion. तो फिर limits change होंगी क्या उसके हिसाब से?
You take the exit conversion as 90% conversion, right?
Okay, XA की value.
XA की वैल्यू दी हुई है exit पे.
Okay.
Okay. And okay. So in the plug flow reactor, XA changes as distance changes, right? As you move forward in the cylinder or in the reactor. So and in CSTR, the XA is same throughout, right? Except the entry point. I mean, XA is same as the exit because in CSTR you have mixing, but here you don't have mixing. So XA exit is given as 90%. Okay.
Okay.
Sir, in the V equation, there is missing integral sign. Is there anything else more missing?
In which equation?
In the
Which
second question, V.
Second question.
V equation.
So V equals, right?
Yes, yes.
So V is the total volume of the reactor. So
No,
there
sir,
should be
I
no
am saying
integration.
about the integration sign. Dxa divided by 1 xa to the power n. Is there any
Yeah.
sign between 1 and xa?
1 minus XA, right?
But sir, is not. Is the PDF updated afterwards, sir?
I also downloaded the same document from the Moodle. Okay. This is a Word file, right?
No, sir. My one is PDF.
So Moodle पे तो भी word file ही है.
Moodle पे Word file है, एक बार चेक कर लो.
ठीक है सर.
सर
हम्म,
सिम्पसन में एक डाउट था. If I have 5 intervals, like 6 data points,
Hmm.
then in that case I'll have to use both the Simpson methods, right? 3 intervals by 1/3 and the other by the 3/8. 3 plus 2.
Right. Hmm.
Just confirming.
Right. So if the number of data points are a multiple of like multiple of 2, you need to use the data if the number of data points are in the multiple of 2 plus 1, I think, right? Because you need one more for the end point. So
Yes, sir.
right, so in that way, in that thing you have to use Simpson's 1/3, right? And so if the number of segments are odd, so you cannot use Simpson's 1/3, right, in that case, because you need to have 2 segments for to apply one time the Simpson's 1/3 formula. But that's all you need to remember. And for Simpson 3/8, you need to have 4 points to apply the formula and then move on to the next 4 points. Okay.
But then the 2 plots need to be different, no? I mean, the method-wise plot we have to report in question 1. They'll have to be different. So that's why I was asking if I can use mix of both.
Okay. So take probably you all can take it as uniform and take the x-axis for which you will plot x-axis as the number of data points, I think. So take that. Okay. And for trapezoidal rule, it will start from 2, 3, 4 and all. Okay. And for Simpsons, what will you have? Number of data points, it should start from 3, then 2, and then again 2 segments, 1, 2, 3, 4, 5. So 3, 5 and so on. Like that you should have number of data points. So, is that fine? Now take x-axis as number of data points rather than number of segments, so that should make it uniform. Okay.
Yes.
So you should be starting your term paper. You don't have much time because I think the major schedule has also come. So you have, I think, 3 weeks more probably before the
फिर कब
major
होगा
starts.
लाइक कब सबमिट करना होगा
डेडलाइन
हाँ
अभी बता देंगे तुम्हें, अभी हमें भी नहीं पता है डेडलाइन.
सर लाइक
मैम
अप्रोक्सीमेटली
फाइनलाइज.
पीएमटी के बाद पीएमटी कितने दिन बाद होगा लाइक पीएमटी के आसपास पीएमटी 11th को बोला ये लोग देंगे 11th नवंबर के आसपास
पीएमटी
तो हाँ
मैम ने बोला पीएमटी 11th को देंगे.
हाँ जो वो टाइम टेबल है वो वाला यूजी वाला
ओके.
उसके साथ
हाँ तो फिर आई थिंक उसके आसपास ही होना चाहिए बिफोर योर, आई थिंक बिफोर योर classes are over, I think before the last class is over. So take it as 2 or 3 weeks maximum. So you need to submit it before that. So I will finalize it with Jayati ma'am and then convey the deadline to you. I think we have missed that we have not conveyed the deadline. So we'll do that. But I hope you will all have formed the team and started working on your paper. So that's the thing I wanted to remind. Okay. If anyone doesn't have any doubt in this tutorial, then we can end it. Maybe I can stay for 5 more minutes.
So I had a doubt about the Viva that was to be held last week.
Okay, so Viva, I have not so I usually update it a day before or on the morning of the Viva day, right? So I have not updated. That means that Viva is still postponed and is not yet finalized that on which day we'll be taking. So we'll convey that to you. So don't worry. At least one day before, or at least 6 to 8 hours before the Viva, I will update it, right? If Viva will be there. Anything else you wanted to ask?
No, so that was it.
Okay. Okay, so I want someone to volunteer and make a list of people who have not given their first Viva also and send it to me. Okay. Or maybe convey that to your friends so that if all of you present here have given the Viva, then other people will know that. So, so the idea is I want to finish the Viva for the people who have not appeared in any one Viva also. Okay. And then we'll move on to the next phase if that will happen. Okay. So another 3 minutes, then I will close the session. So please read it once again, the tutorial. If anyone has doubt, you can ask now. So Manan, you are here, right? So can you make the list of the people who have not appeared for Viva? Hello. So Manan also should be on the list. So please tell him to make the list, and also the reason for which they have not appeared for the Viva. Okay. I'll also write that in the chat.
Sir, I'll take my leave.
Okay, you can leave. Those who have no issue, they can leave.